Hello everyone, welcome back to Travel with an Engineer. In previous episode, we visited the city of Sutter Creek and we discussed the history of its industrial heritage. And we noted that the Miners Bend Park is a part of the Amador County Industrial Heritage Corridor in Sutter Creek, along with Night Foundry and Central Eureka Mine. I decided to visit this park in a separate video because while the old mining equipment can be found all over the California's Gold County, but this little park perhaps has the most comprehensive original equipment that are on display in a proper context. So this park might be a good place to discuss a little bit about how the mines operated and some of the main machineries, equipment that are used in old gold mines. The park used to be one of the parking lots at the south end of Main Street in historic Sutter Creek, and it was converted to a kind of historic theme park where historic mining equipments are in display with many informative flags. These minor statues that you can see here were not originally designed for this park. In fact, they first designed for a corporate office building in San Francisco in 1976. But later, that corporation redesigned its courtyard, so there was no need for these statues. So someone bought them and then transferred it to Sutter Creek and donated them to the Miners Bend Park. Now let's take a look at some of these equipments in the order of where they were used for the extraction of ore from the mine to transfer of the ore out of the mine and then finally processing of the ore to extract the gold from the ore. The first step in hard rock mining is breaking the rock within the mine, usually underground. And the most primitive method for this purpose is using pickaxe. But obviously, this required back-breaking hard labor, particularly in underground mine environment. A more advanced method for this purpose is blasting rocks using explosives, initially gunpowder. For this purpose, first some holes needs to be drilled on the mine walls so the gunpowder can be placed inside those holes prior to the explosion. These holes are called blasting holes, and initially they were created manually using sledgehammer and drill steel. And there were two ways of doing it. One was one man's or what was called single jack. And as the name implies, one person hold the drilling steel with one hand and operate relatively small sledgehammer with the other hand. And the second method was two men or double jack method, which there were two or three people. One hold the drill steel in place and the other one or the other two use large sledgehammer to push the drill steel into the wall. Now, using black powder or gunpowder for the purpose of explosion in the mine was very risky, especially considering the unreliability of detonators. And many miners were killed or most likely injured by untimely explosion. But later, the introduction of electric detonators, nitroglycerin, and finally dynamite throughout the 19th century progressively made this process safer and more reliable. But still, manually drilling the blasting hole was a very difficult process, as you may imagine. So in the second half of the 19th century, compressed air rock drills were invented and they were introduced to the mining industry, first in Europe, later in the United States. And over the time, their designs were improved. In these tools, the drill steel was forcefully thrown at the rock by a cylinder and piston assembly powered by the expansion of high pressure air. The high pressure air was produced on the surface by using compressors, and then it was sent to the mine. And as a bonus, this discharge air from the tool also helped the mine ventilation because the air again was fresh air compressed in the surface. But the early designs of these drills suffered from clogging of their mechanism by the broken rocks. And later, this problem was solved by blowing high pressure air into the mechanism. So it kept broken rocks and dust away from the internal mechanism. But this in turn was a problematic because the flow of high pressure air created a lot of dust, and many miners suffered from respiratory diseases because of inhaling this dust. Later, this problem somewhat addressed by adding water spray to the process to reduce the dust. Here you can see one example of these compressed air rock drills. So the blasting holes were created using drills, the explosives were placed, and the rocks were broken by the force of the explosion. After the gold ore mixed the waste were exploded and prepared, they must be transferred to the surface for processing. This meant loading the ore and waste to the cars, move them to the shaft, and hoist them out. The first step, the loading of the material to ore car, is called mucking. A skip or bucket is a car that carries everything, including ore and waste rock, men, equipment, water, and material, into the mine or out of the mine. Until the 1930s, the loading process was manual, but later mucking machines were used that we will discuss just in a second. The loaded skips or buckets or mucking machines then were pulled or pushed on a track to the main shaft by the manpower, by mules, or later battery powered locomotives. So here you can see a simple skip or bucket, but this one is mucking machine or mucking shovel, which, as you can see, this machine could load the car, could transfer it to the shaft, and unload it. Now the ore is at the main shaft and somehow needs to be pulled out of the shaft to the surface. And this is done by a hoist. Hoist is used to pull out the skips and buckets out of the mine shaft or lower them down. A hoist could be powered by horses, by mules, by steam engines, or electric motors, usually with an steam engine as a backup just in case when the electricity is not available. The hoist mechanism has a drum or drum reel to collect the cable when the skip or bucket is being pulled out of the mine, or feed the cable when they are lowered into the mine. There were single drums, which also were known as VIM, or two drums, so they can work with two skips or buckets at the same time. Now, a main mechanism for the hoisting process is a head frame. A head frame is installed over the entrance of the mine shaft, and its function is to assist the hoisting process. So the hoisting cables, starting from the drum in the hoist room, passes through the sheaves wheel installed on the top of the head frame, and at the other end the cable is connected to the skip or bucket. And depending on how large and how deep the mine is, the head frame can be a simple wooden structure or steel structure. And they can even incorporate other functions such as crushers and ore storage bins. Now, one of the major problems with any underground operation is that if you go deep enough, almost always some water will be accumulated in that underground facility. In this case, underground mine. And that's why an underground mine needs a constant dewatering, removal of water from the mine. And usually the deeper the mine goes, the more water removal is needed. And for this purpose, typically a sump is created at the bottom of the main shaft. So the water is collected in that sump, and now that accumulated water needs to be removed. In early mines, that collected water was scooped or baled by a large metal bucket and hoisted out of the mine. Sometimes that bucket is called water baler. And the amount of the water that needs to be removed sometimes was just enormous. In the Kennedy mine in nearby Jackson, 80,000 gallons of water bailed out every day. Now later, special pumps coupled with electric motors were used to pump this water out of the mine. And as you may know, unlike compressors that can be installed on the surface and the high pressure air could be sent via a duct system into the mine, pumps needs to be installed near the source of the water. So these pumps typically had a special design. So the part of the pumps can be lowered into the mine and then it can be reassembled underground near the sump so they can pump the water out of the sump to the surface. Here you can see one of those pumps. Now back to the mining process, we saw that we hoist the ore and waste rocks out of the mine. Now we need to process that ore. And as we discussed in the hard rock mining, the gold pieces are trapped inside the hard rock. So in order to release them, the rocks should be broken to very small pieces. Now, there were several early mechanisms to pulverize the ore, but the most common one was what was called stamp mills. Historically, stamp mills were used whenever solid pieces needed to be pulverized. In these stamp mills, ore was crushed by the force of stamp shoes that were connected to a shaft falling under the gravity. Each shaft was equipped with a tappet or lever that was raised by a cam connected to a camshaft. So the camshaft rotates and the cam raises the shaft and stamp shoes via the tappet. Now the camshaft was powered by a water wheel, a water turbine, or a steam engine. In this particular case, you see that a water turbine is used to run the camshaft. Later, when we visit the Night Foundry and Nevada City, we will have extensive discussion on the operation of water turbines. A typical stamp mill was composed of 5 stamps in a battery box. So the ore that came out of the mine first pre-processed, pre-crushed, and then it was fed to the back of the stamp mill along with the water flow, a lot of water. The ore was crushed under the stamp shoe and pulverized. When the pieces of rocks were small enough, they were carried by the water flow and they passed through a fine screen. And that output was fed to what is called amalgamation table. And this table was covered with mercury. So the mercury reacted with the gold and trapped the gold pieces, which later was extracted from the mixture. Besides these main equipment that we discussed, there are other miscellaneous tools and equipment on display in this park as well. I know today we covered a lot of ground that might be a little confusing and disorientating, but don't worry, as you may expect, there are plenty of museums and displays of mining equipment, and when we visit those places, we will discuss a little bit more about details of this equipment and different variety of them, how they work, how they evolved, etc. So don't let this video to intimidate you. It turns out that you don't need to go far for another display of old mining equipment. Just on the other side of the Sutter Creek, there is another extensive display of these equipment. And considering how small Sutter Creek is, this other side of the city means just less than a mile away. couple of minutes drive from Miners Bend. This display is located in the parking lot of Sutter Creek Fire Department. This is a water nozzle that is used in hydraulic mining, where the jet of water at very high speed is used to wash away entire hills, and then the gold is extracted from the mud that is created by hydraulic mining technique. We will have extensive discussion on hydraulic mining techniques when we visit Malakoff State Park, just north of Nevada City. This is an ore car that is used to transfer the ore either within the mine to the mine shaft so it can be hoisted out of the mine, or it can be directly pulled out of the mine to transfer the ore to the ore processing facility. As you can see here, this ore car is equipped with a relatively simple unloading mechanism, so the ore can be easily unloaded from this ore car. This is a gate valve to control the water flow in the pipe, typically used in the hydraulic mining process to control the water flow to the water nozzle. Here you can see a drum reel for the hoisting mechanism. And as you can see, this drum reel has two drums, so it can operate two skips, two ore cars at the same time. This one is a small ore bucket that can also be used as a water baler bucket. So depending on the need, they could load this bucket with the ore or with the water that is accumulated in the sump so it can be hoisted out of the mine shaft. This one is a larger, more sophisticated ore bucket or a water baler. This is a Pelton water turbine or water wheel that is used to extract the kinetic energy of the water flow and convert it to rotational motion so it can be used to power wide variety of equipment, including stump mill that we saw previously in this video. We are going to have an extensive discussion on the history of Pelton turbine when we visit Nevada City, and to lesser extent when we visit Knight Foundry in Sutter Creek. Here you can see another ore bucket and water baler bucket. This is Sutter Creek's first fire bell that installed in the first decade of the 20th century. As you can see, there are a wide variety of miscellaneous items related to mining industry in this display. And as I said, we are going to see many of similar displays when we visit almost every city in the California's gold counties. Just as usual, keep reading, learning, and traveling and visiting wonderful places. Thank you. Bye.